Today, the position, navigation and timing services are integrated into the very fabric of our digital world. The applications are rapidly increasing across sectors and has transformed businesses in a range of industries from farming, construction, transportation, aerospace, automobiles, autonomous systems to lifestyles with innovative products and services. It directly affects economic activities and economic growth worldwide by increasing efficiencies, reducing operating costs, improved safety, environmental quality, and has delivered many other qualitative benefits. As PNT becomes even more important to the economy, any disruption in availability, reliability, resilience, and integrity would weaken the critical infrastructure that sustains our national security, business operations, and public safety. To build resilience into these systems will require multiple technologies ranging from network time transfer services, terrestrial wireless infrastructure, and low Earth orbit satellites. Let's understand the value proposition of diverse PNT technologies to strengthen economic resilience globally.
My name is Robert Cardillo. I've got the privilege of moderating our next panel. Before I begin those duties, though, I must add my congratulations to my friend Sanjay and his team for their 25 years of success, and remind all of us that the key to that success is, quite frankly, a little bit of agility and a little bit of flexibility. So we're beginning our panel a little behind the scheduled time. We'll flow just a little bit into your coffee break, and I know many of you are in different time zones right now. You will get your coffee here shortly. But again, it's my privilege to be part of this panel. I concluded my federal service 3 years ago as the director of the National Geospatial Intelligence Agency. Now, in my current role, I seek to continue to contribute to that public-private partnership that has been described here on the stage. And chief among my current duties is to chair the board of Planet Federal. As I said, it's both a professional and a personal privilege to be here with you this morning and to host what is a powerhouse panel. We're going to sustain the momentum that's been generated both by our guests in person and our friends virtually, from the Prime Minister to Jack Dangerman. A quick comment, Sanjay, on the theme, which I couldn't agree with more, geography and humanity. And if I could add just a slight modification, I would also say that geography is humanity and humanity is geography. Quite frankly, and the other piece is the introduction of storytelling right up front. As director of the National Geospatial Intelligence Agency, I could appreciate the importance of our role and responsibility as a member of the United States intelligence community and our responsibility to the Department of Defense as a combat support agency. But even so, I was quite comfortable reminding my teammates that we're in the storytelling business because we're communicating information from human to human for the betterment of all of us. And it's no different whether you're doing that at a very senior national level or you're doing it here at the conference or at the coffee break. It's literally how humans transfer individual information for collective good, for society, for security, for sustainability. And quite simply, our existence on this planet has been shaped by our individual and collective awareness of place, and our confidence to be able to move securely and efficiently from one place to another, all within that common framework of time, position, navigation, timing, or PNT. And I can think of no better way to set the stage for this critical discussion about the importance of PNT and our economy, both today and tomorrow, than with a presentation from a true legend in our profession, Charlie Trimble. Our guest speaker was the driving force behind the creation of the first commercially viable GPS timing receiver in 1984. Charlie's contribution in the field created the very foundation for the vibrant and socially relevant geospatial industry we all enjoy today, His vision has empowered industries in this room across every sector, making a profound and lasting difference in the world economy and society. Please join me in a warm welcome for Charlie Trimble.
The topic of the session, positioning, navigation, and timing, and world economy, is a bit broad and ambitious, but anyone that knows Sanji is not surprised. So here goes. This smartphone is a wonderful example of how far PNT has been integrated into our lives. It's almost impossible to think of how we would get through the day without it. And yet, if we go back 65 years, the smartphone was not an obvious consequence of the launch of the first satellite. Indeed, the path from the dawn of the space age to the smartphone was anything but obvious or straightforward. I now see, in retrospect, that there were three basic steps that were involved in leading PNT to its place in the world economy. First, Sputnik led to the global navigation systems. Secondly, the shuttle disaster led us to the realization that the satellite system was an information utility. And now the integration of PNT into the mobile and the mobile internet into the cloud is changing our world. Our story starts in 1957 with the launch of the first satellite. This provided us with an existence proof that global positioning was possible using satellites. It inspired the 5-satellite US government transit system. Global positioning was good, but real-time global navigation would be even better. And to do that, we needed to measure both position and time simultaneously, and then update it in real time. These were really the specifications or what led to the design and development of the GPS system. In 1976, the first GPS test satellite went up. 8 years later, in 1984, forgive me, George Orwell, Trimble, a fledgling startup, sold the first commercial GPS receiver. There were only 5 satellites in the sky at the time, and early applications were niche markets like oil survey or synchronizing timing centers. But looking forward, the strategy was focused on what we perceived to be a $1 billion annual market in car navigation. The second phase basically was triggered by the shuttle disaster in January of 1986. There were only 7 GPS satellites in orbit when the system was put on indefinite hold while a new rocket capable of launching the satellites could be developed. The bad news was that this put an indefinite delay in the widespread use of GPS for navigation. The silver lining was that it compelled us to think deeply about the value proposition of GPS. We started to realize that the data that we were getting from geotagging things and time-stamping events possessed useful information for connecting things in space and time. This then led us to the realization that the satellite system itself was an information utility. And as a matter of fact, a free utility. We focused our energies on using GPS information to improve productivity. And so by the turn of the century, markets for land survey, GIS, mining, construction, precision farming, search and rescue, emergency response, synchronization of power and communication systems, and even bank transfers were all part of the PNT story for Trimble. The third phase has to do with the integration of PNT information and the mobile internet into the cloud. This is, figuratively speaking, absolutely weaving PNT into the fabric of the world economy. It started really with the integration of GPS into the cell phone. This connected the mobile common carrier with GPS PNT information. The addition of ranging signals from GLONASS, Galileo, Baidu, the Indian and Japanese systems were added to the mix. Then came PNT augmentations, multiple sensors, vision systems using AI and deep learning as critical components of autonomous drones and robotics, self-driving cars. Add in augmented reality to vision systems that were embedded in software tied to data and computation in the cloud, and you get a glimmer of what the future is about to bring. What I've tried to do today is to shortly sketch the story of how PNT has become integrated into the world economy. It is truly changing the way we live and work. First, there was Sputnik that led to GPS and the other satellite navigation systems. Then there was the shuttle disaster that caused us to realize that the satellite system was an information utility, and it was PNT information and not so much the devices that were important. And finally, the integration of PNT information with the mobile internet into the AI infused cloud, sets the stage. So, is this the end of the story? I think not. Stories are fixed and rooted in the past. It is you who hold the keys to creating the future. I challenge you to innovate. Thank you. All right. Great. Thanks.
See, I didn't over-advertise that. What a wonderful laydown, Charlie, of our history. Quite frankly, your history and your contributions, our deep thanks to what you and your team has done to contribute to where we are today. Could I now invite the rest of the panel to the stage, Sir Martin Sweeting, Rodrigo da Costa, and Gillian Smith. Please join us up here. What we're going to do now is walk through some brief introductions from our additional panelists, and then we'll turn to some Q&A to include yours. So I would invite you to be prepared for that. Sir Martin Sweening is the Executive Chairman, Surrey Satellite Technology in the United Kingdom. Martin, could you kick off, please?
Very, very good morning to everybody, and thank you for the opportunity to address you. It's really fantastic to, after 2 years of seeing everybody in 2D, to be able to actually now see everybody in 3 dimensions. I'm representing perhaps a slightly different audience that would normally be here, and that is the infrastructure provider, because I am a spacecraft manufacturer and engineer, and it is that which I'm going to just touch on for the moment. And if we could move to the next slide for me. So whilst I'm essentially in orbit, my experience in PNT goes back a long time. In fact, I only just realized that Surrey Satellites was formed just a year after Trimble. And in fact, our first contract was with the European Space Agency to look at the feasibility of producing a navigation and timing satellite using small satellite techniques, which in 1985 was considered a pretty wacky idea, but now it's a very fashionable activity which has really, I think, changed the face of space. And from that time, in roughly 1986, some 25 or 20-some years later, we then finally achieved what we said, which was to participate with our colleagues, OHB, in the design and manufacture of all the PNT payloads for the European Galileo system, which is now fully operational. So I have had a long background, not just in the spacecraft provision, but also in PNT. And moving to the next slide. And of course, now we see GNSS used not just on the ground, which is perhaps representative of most of the audience here, but also in space, because the PNT signals are used increasingly for the autonomous management of constellations of satellites, whether they be the relatively small constellations of Earth observation spacecraft, or now the growing range of mega constellations of thousands, possibly soon tens of thousands of satellites in low Earth orbit. And this contributes to the efficient management of the orbital assets, both for Earth observation and communications. And the whole role of using PNT in orbit is continuing. And back in 1998-2000, we started to look at Surrey at the possibility of using GNSS reflectometry, which in the early days was considered a possibility, but an unlikely successful operation, through a series of experimental payloads over the next 20 years to demonstrate that GNSS reflectometry can provide an operational and useful service. And just recently, we have embarked on a project with the European Space Agency called Hydro-GNSS, which is to use GNSS reflectometry to address a number of the climate-related issues associated with water detection, whether it be permafrost or biomass and so forth from the Earth. These are long-term combinations of academic research through demonstration leading to operational systems that have taken decades to mature, but now are the use of PNT. And the next slide, please. And it doesn't stop there. We are looking now not on the surface of the Earth, but we're now looking at the use of PNT in the upcoming lunar economy, where the rejuvenated interest in lunar exploration will involve sustained or prolonged human habitation on the surface of the moon. And there, one crater is going to look very much like the next, and we're going to need exactly the same infrastructure and services on the lunar surface to control not just and aid human exploration on the surface of the moon, but of course what will be extensive robotic exploration and exploitation of the lunar surface. And this will then connect the experience that we're getting here on Earth in driverless cars with the robotic exploration and human support on the lunar surface. So we can see that PNT has indeed, as Charlie said, a very strong future, not just here on the Earth, has been very ably described by previous speakers, but also looking through this decade into the use of PNT on the lunar surface. So it's a great privilege to be here and interact with a different community than I normally interact with, which is on the spacecraft orbital side with the wide range of user exploitations. Thank you.
Thank you very much, Martin, for that. And if I could add my thanks to your contributions to where we are today. Arguably, you're the father of the small satellite industry, quite frankly. And I'll just say from Team Planet, we thank you for the path that you set. Next, I'd like to invite Rodrigo da Costa, who's the Executive Director of the European Union Agency for the Space Program, to make some opening remarks. Rodrigo.
Yeah, thank you very much. Okay, it's already working, the audio, so quicker this time. No, thank you very much. First of all, thank you very much to the organization for inviting us, inviting me to be here today to tell you a little bit of what we are doing in the European Union and in the frame of the space program on what concerns PNT, but not only, because now our mandate goes a little bit beyond that. It may sound to some of you that it is the first time that we are here. Well, that's not really correct, because our agency is a long-term partner of Geospatial and the Geospatial World Forum, but we had another name before. We were called the European GNSS Agency. And since 1 year, so the GSA at the time, and since approximately 1 year, we are now the European Union Agency for the Space Program. If you go to the next slide, please, you will see what is now the European Union Space Program. Some of these things that the European Union is doing on space, they have been done for a while. Some of them were already mentioned. Of course, Galileo, the global satellite navigation system, the navigation system of Europe, EGNOS, our regional augmentation system. These ones dedicated to the navigation world. On what concerns Earth observation, Copernicus, providing a large amount of data from satellites, but also in situ measurements. And new things happening in particular in the area of governmental satellite communications, space situational awareness, and others. Whereas in the past, all these activities were taken separately, now, since 1 year, they are taken in an integrated manner. And this is quite important, and I think it is quite important in particular for this audience and for this conference, because it is about the potential for creating synergies among different types of data and services we receive from space, be it in the area of PNT and navigation, in the area of Earth observation and telecommunications as we will move forward. We as an agency are, of course, dedicated to some particular tasks. The service provision of Galileo and EGNOS, so 24/7, making sure that the signals are performing as expected. And everything related to the security of the elements of the program. This means also security operations, security of the space assets, but also making sure that Galileo and EGNOS, in the future Copernicus and GovSatcom, can also be used for missions related to our security. And last but not least, fostering the utilization. Because all these programs are obviously massive investments, very important investments, and in the end the result comes from their utilization in the different areas of our economy, in the different areas of our daily life. Whenever we are looking at the utilization, we are looking at the utilization of these elements in separate, so fostering the utilization of Galileo. Today, worldwide, estimated more than 3 billion receivers already equipped with Galileo. Also fostering the utilization of EGNOS, with a focus, of course, in Europe. On what concerns Copernicus, the commercial use of Copernicus. But what is more important is now to go to the next step and ensure that those systems and those capabilities are used in a synergetic manner. And this we do by working, of course, with large companies, small companies, a very particular focus on small and medium enterprises, on startups, innovators, entrepreneurs, to make sure that we grow a competitive industry that in the end will also be the industry that will bring us the necessary resilience that we need towards the future. Next, please. Now, when we look at the markets, obviously, we look in many different segments, and now with the addition of Copernicus to our traditional portfolio of navigation. We have identified a total of 17 market segments, and I've seen with quite some interest that many of these market segments will be tackled in the afternoon and in the next days on the different sessions that will take place. I've seen that there will be discussions about agriculture, about transport, etc., etc. So these are the segments where we see the use of space data. These segments are important. This segmentation is important, obviously, because it is here that an industry and the downstream industry will create value, will create applications. But, and now I would like to reflect for a moment also on the specific theme of this conference right now. It is the link of all of these with humanity. Next, please. And here, it is important indeed to relate how our activities in space, I'm focusing, of course, on the European Union Space Program, how our activities in space help us achieve the SDGs defined by the United Nations. And we see very clearly that out of the 17 SDGs that were defined, 13 have very clear have a very clear contribution and a very significant participation of space and space data. And I think this is important to help us reflect, because many of the businesses, the ideas that we are creating, they are not only good for business, but they are indeed contributing to the progress of our humanity, which is in particular important in the current situation we are right now, that was already addressed in the previous talks. Next, please. To give an overview about all of these, some of you may know, we publish a market report. Until this year, we were focusing with our market report on the GNSS market. Since this year, so since this new edition that came in the beginning of the year, we have enlarged that market report. Now we are also focusing on Earth observation and GNSS, which will help you and will help the community to see what is the potential for use of Earth observation and satellite navigation data in all these different segments. I would invite you to read it, have a look at it, and I will conclude when we move to the next slide. There is a short video presenting our GNSS market report. Thank you.
Thank you, Rodrigo. Rounding out our panel, we have Gillian Smith. Gillian is the Vice President Marketing for NextNav. Gillian, please.
Hi, everyone. I'm Gillian Smith. Nice to be with you all today. Our CEO and co-founder of NextNav, Ganesh Pattabiraman, unfortunately could not be here today. So, yes, I'm thrilled to be here in his place. And thank you, Sanjay. Thank you, Robert. But we've gone from the history here, thank you very much, Mr. Trimble, for giving us that overview, into the moon and outer space, and I think I'm going to bring us back down to Earth. We're talking about the world economy, and just in the US alone, GPS is approaching about $1 trillion annually in terms of its economic impact, and it's doubling every 2 to 3 years. But it is a single point of failure. We are relying on it for so many different things, as we've talked about and as the opening video also shared. And we believe that our needs have evolved beyond technology that was really created in the 60s. We need increased accuracy and availability in urban environments in particular. I think many of you have experienced, if you're trying to use in any major city, that blue dot is going to bounce off of buildings and not be very accurate. We need indoor tracking and mapping. We need altitude data so that you know what floor actually you're on when you're thinking about that accurate location. And we need increased resilience and redundancy. That's also going to give us all increased security as well. So what is NextNav? NextNav is, we like to refer to ourselves as next generation GPS. It's more available, more resilient, and more accurate. But I want to go back a little bit, not that long ago, and then just talk about even just the last 6 months in terms of the vulnerability that we are all facing right now. So I believe there were incidents beforehand, but the first official, I would say, incidents that the government recognized in the US of GNSS spoofing was back in June of 2017, that there were more than 20 ships in the Black Sea that were reporting issues with their navigation systems and showing that the ships were at a Russian airport when they were not. Back in 2019, there was a DC think tank that documented more than 10,000 cases of GPS interference in the last 5 years from Russia, including that Putin is intentionally spoofing his location and jamming GPS signals wherever he travels. Back in June 2021, this was incredibly sophisticated. There were NATO ships that were in Odessa, and all of these generals were actually seeing on their machines and equipment that it looked like they were in the Crimea when they were not. A really sophisticated level of spoofing. So just in the past 6 months, what are we really looking at here with the threats? In November 2021 and ongoing, we see an increased amount of GNSS interference and spoofing within the Ukraine ahead of the Russian invasion. In November 2021, I'm sure most of you are familiar with this, that Russia shot down its own satellite and announced on state television after it did this, that they could take out all of the GPS satellites used by NATO as a warning not to interfere in the Ukraine. Just this past March, the EU's Aviation Safety Agency is warning of GNSS spoofing and jamming in aircrafts with noted incidents and flights over Europe, in particular around Finland and other countries that also neighbor the Ukraine and Russia. And the Defense Department has noted that we actually haven't even seen as much as we know that the Russians can do. So what does that mean, and where does that leave us? If we talk about the fact that GPS is really vulnerable, well, we have a couple of technologies that we think are very helpful, and of course, I want to share a little bit about those. So the Pinnacle technology is what we have, which provides vertical location. So that actually provides what floor of a building you are on with the z-axis that goes with the x and y of the horizontal GPS coordinates. It is currently in use throughout the United States. We have it commercially available in more than 4,400 US cities and towns. We also have an active pilot in Tokyo, Japan. And this is currently in use by public safety. One thing when we did the history lesson that Mr. Trimble shared was that we didn't actually talk about, well, what were sort of those accelerators? It really was public safety, as a lot of people started to be on mobile phones much more, and they didn't have the landline when they called the emergency services of the 911 in the United States, or 110, 112. You didn't know where they were. I think many of us remember that you couldn't actually know where you were when you had a mobile phone a long time ago. Well, we've come a long way now with the chipsets that everybody has in their phones. But in the building that you're in, if you do not know what floor you're on, or you cannot communicate what floor you're on, otherwise you would not be able to be found. This is now coming in the United States. There is a new federal communication mandate that is coming out already right now, and at NextNav we've announced that we have a top wireless provider that is going to start providing that vertical location for 911 emergency calls. So this is now coming. It's happening to know what floor you're on, and those consumer expectations are going to change with that. But the important thing is, there is an estimated 10,000 lives in the United States that will be saved by enabling that technology. We think about right now in a pandemic, when people can't breathe and they call emergency services, if you can't know where they are, that's going to be a big problem, right? So very excited about this, and the data also shows that it can reduce the response times to get to an emergency caller by about 80%. Now, the one technology that I also really want to talk about that we have in the United States, only commercially deployed within the San Francisco Bay Area, but also initially deployed in other campuses in NASA Langley, and then also we have a campus in Japan, and we have an initial deployment in other markets in the United States. And that is a terrestrial version of GPS that gives the full 3D positioning, navigation, and timing. So it's a ground-based solution. This is not a satellite-based solution. And as I said, it provides that full X, Y, and Z coordinates. And it's a broadcast signal on our own dedicated spectrum, and it has unlimited capacity. It's a resilient signal. It's encrypted, and it's actually, I think, closer to 100,000 times stronger than what you would get with GPS. And as I mentioned, only initially deployed, in the US and a little bit also in Asia, but it actually is not a huge lift to be able to deploy it, and you need only about 10% of the transmitters that you would normally have with a wireless network. So the other thing that is happening right now in Europe is we were one of, I believe, 8 companies that has participated in an EU a joint research center trial for PNT services in a GPS-free environment, and that demonstration day is actually next week. So between not just talking about the vulnerability, but really enabling what we're looking at for the future. We think about drone delivery and autonomous vehicles and urban air mobility, and really that critical infrastructure and securing that critical infrastructure. And when we talk about the sustainability, we talk about climate change. We want to make sure that we can also make sure that we can find people in emergency services, but also enabling all of the technologies in the economy that relies so heavily on PNT services. So now, I wouldn't be American if I didn't say that we weren't we're the best technology, right? That's what Americans always say, that we're the best. And as a marketer, I have to say that as well. And we did score the top of all of the technologies tested in the US Department of Transportation report, so a shameless plug for our results on that. All that being said, the truth is we do not believe we are the only solution. And we talk about collaboration and what is needed, and we know that there are multiple solutions that are needed to secure our critical infrastructure and to secure the importance to the economy, that between LEO satellites and so many other technologies that are available, and we really do need to focus on that. But if there's one thing that you all take away, please believe and recognize that we need a resilient layer to GPS. So, thank you.
Thanks, Gillian. All right, team. We're a team here. And you've already recognized, Charlie, through your history, and Martin, it's an enormous topic, right? We could spend a whole conference on just this topic, but we don't have that time. So what I'd ask you to speak to next is just that word, next. So what's on the horizon? Charlie introduced, the stages and the history. Martin, you kindly threw out the moon as next. Gillian, you talked about resiliency as you did, Rodrigo. But thinking about this room, thinking the industries are here, what is it you need from the room, right, in order to get to what's next? And maybe we'll start with the moon, Martin, as a challenge?
Yeah, well, yes, it is a challenge. I mean, and answering a different question, because you said
That's
that
That's how the team works.
as a good politician.
Yeah.
But I represent both the commercial and the academic community in our activities in the UK, because I am involved in the robotics and autonomous systems in the UK as well as the space side. And what I really would like out of this conference is actually to listen to you, because I'm the provider, if you like, of the space segment. And I want to understand what are the problems, what are the ideas and issues and requirements and new concepts that you as that community have. And I pick up very much on this question of resilience, of the need for having multiple layers, multiple technologies. You cannot just have one. They don't suit they don't address all the requirements. So it's having that network. And then, of course, if we do go on to talk about the moon for a second, this is going to be a big challenge. Because again, putting an infrastructure there's going to be multiple nations on the lunar surface, and we're going to have to somehow find a way where we don't end up with the interference issues that we have seen here on Earth, because human life again will be at risk. And I'm just hoping that in that environment it will be a collective industry of self-interest in preserving that environment for PNT, which will help. So I think there's some really big challenges, both in the technology, but from my side, I'm really interested to hear what are the requirements, and I will try to address what is the art of the possible from the space segment in trying to meet some of those challenges from this community.
Well, you're at the right conference, and you've got the right exhibitors on the floor to help get to those answers. Charlie, maybe for you, could I ask you, you talked about the 3 chapters in your presentation. What's the 4th chapter?
The 4th chapter is actually not up to me. It's up to this audience. And when I'm talking about creating the future, I'm not simply talking about instrumentation and sensors and information. I'm talking about the political and social systems that make use of the information and actually deliver the promise of technology to society.
Wonderful. Rodrigo, you sit in an interesting space between, no pun intended, between government and industry, public and private. What would you like to see? What behaviors or maybe some rule-making policy changes that could enhance the interdependency, which we know exists between the two? Is there something getting in the way of that partnership?
Yeah. Thank you very much. First, let me just reflect a moment also on what Martin just said, and I think this is very important, which is for us, working, let's say, from your point of view on what we call the upstream, it's very important indeed to listen. What are the needs? What are the needs in the different markets? On what concerns Galileo, I can tell you, I can certainly state clearly that Galileo is evolving and will continue to evolve. Right now, for example, resilience being a key element, we are testing the navigation message authentication, which we believe it's going to be an interesting capability. And as soon as this test phase is through, we really hope to see it coming to the industry, to the different applications. Same is happening with the high accuracy service, but also looking to the future. The 2nd generation of Galileo is in the make. A number of capabilities and things are coming, and there will be a 3rd generation and a 4th generation. So also the satellite systems will continue evolving, and for us it's very important to make that bridge between the needs and the evolution, which is fundamental, because in the end the success of all these programs and also the success of Galileo is related to the use that it is given to it. And in particular, and I think there is a strong link, there is a very important link between what governments and, let's say, institutional actors can do and what private actors can do. On what concerns the institutional actors, one of the things we are working with a lot of intensity is on the topic of standardization. And of course, we apply to, let's say, our perimeter, which is the European Union, but can be important also in other countries, in other continents, with the fact that, for example, with the e-call regulation, all cars homologated in Europe after sometime in 2018, they have to be equipped with Galileo. Since March this year, whenever you do a 112 call from your smartphone, the position has to be communicated with Galileo. These are legislative efforts that, from our point of view, will, let's say, also motivate the industry not only to comply with those, because compliance is obligatory, it's the law, but also to build things on top. And we are really looking forward to see what the things that are built on top will be.
Wonderful. Gillian, you made a strong case for NextNav's leadership in the technology category, and congratulations on those achievements. You and the rest of the panel also acknowledge that there is no one single solution. How are we with respect to interoperability, standards, interfaces, et cetera? Are we ready to work together?
Well, first, I also want to comment on a couple of the things that were shared up here. I think it's great to hear, and I agree that there are things that the government needs to do and there are things that the private sector needs to do. And I do think, in particular in the United States, as I mentioned, we believe in multiple solutions, as you reiterated. We are also part of the Open PNT Alliance in the United States, which also advocates for multiple solutions to the vulnerability that we're facing. So I do believe, though, that it is up to the governments to ensure that there is adequate funding for these technologies to be able to continue to develop. And the United States has passed multiple bills on the need for a level of GPS resilience, but have only just started to put just a tiny bit of funding behind it. And I think that there are many more opportunities there, as I believe in the EU as well. But in terms of interoperability, I would also add that we develop our technology with the 3GPP standard to make sure that things are actually going to work. And then also going back to the point that Rodrigo made too, making sure that there is legislation in place for things like, so that the private sector can develop technology so that people can be found in emergency situations, but we're getting much better on the interoperability piece.
Great to hear. Remember what I said, team? Yes, Martin, I'm just going to remind that we're now slipping a little bit into the coffee break, which I warned the audience about. But I'd welcome your entry, Martin.
Coffee is absolutely essential, so I'm going to keep it to a very short thing. But we've focused a little bit this morning on the terrestrial, let's call it the green climate agenda and so forth. But there's an interesting aspect to space as well, because PNT is used now ubiquitously for the management of the constellations, particularly the mega constellations I was talking about. And when we're talking about the potential for interference, one of the issues there is these constellations now mean that there are conjunction warnings that come, torrents now compared to previously, and we need to be very clear about the positioning of our spacecraft in orbit in order that we don't in any way cause problems by increasing the debris field. Yep. So there is a very clear application for PNT in orbit for maintaining the orbital environment as well as the Earth environment.
Charlie?
No, I agree completely, but once you get into the 10,000 LEO satellite realm, you are generating at least scientific interference, if not other forms of interference. You're basically putting a squirrel cage around the world. But there is no, in my mind, there actually is no argument between resilient layers. The satellite system provided a grid that could tie everything together. Clearly, as we need more accuracy and more resilience, ground-based solutions are what are going to come and supply that. Whether they are ring laser gyros for navigation when you don't have information other ways, or you have vision systems. If you look at the self-driving vehicle approach that Tesla is taking, they're basically mimicking in their vision systems what a human driver would do, and basically you can use, the vision systems are going to be the least expensive way of getting really precise position once you're tying into the data and computation in the cloud for the details. I mean, if you want to address the problem of where do you drill the hole to fix the problem with a pipe inside of a wall, if you have stored the data of where all the utilities are before the wall surface has been put up, then an augmented reality system going in that establishes precise position inside of the room from the visual effects is exactly what you're going to use to solve that problem. And so fundamentally it's need that drives the innovation, the engineering innovation in the particular sensors or the systems that you put together.
Thank you, Charlie. I don't know about the audience, but I've got to say that I've become more optimistic as I've listened to not just our history, but more importantly, our future. I want to thank each of the panelists for their contributions for how we got to here today, but more importantly, for what each of you is doing for our collective security, sustainability tomorrow. And I commend the room with the same challenge. That's why we're here. That's who we are, and I encourage each of you to be part of that solution. Please join me in a round of applause for our panel this morning.